Hello, welcome back. Today we're on lesson 2 with Learn with a Doc. My name is Dr. Phillips and I'm from the Science Zone. Thanks for joining us today. Today we're going to learn about some of the amazing properties of water, and you'll learn to do a couple of magic tricks with water as well. Come on, let's learn together. To understand water, we first have to understand atoms. Okay, atoms are the building blocks of molecules. So when we look at atoms, they have a few different parts that we need to talk about. In the middle is what we call the nucleus. The nucleus is composed of protons, which carry a positive charge, and neutrons that don't carry a charge. The exciting part of the atom is on the outside. There are these things called electrons that carry a negative charge, and they orbit around the nucleus. These electrons are going to be what help different atoms form bonds with each other. Now that we understand what an atom is, let's understand that atoms form molecules. So right here, I have a little ball that represents oxygen. Okay. When oxygen forms a bond with hydrogens, so we have 3 atoms that are stuck together, we have a water molecule. Okay. The hydrogens are joined to the oxygen by a very strong bond called a covalent bond. It's really hard to break. That's why water has such a high vaporization point. Okay. So water is a molecule, and how it has been formed by those bonds helps us understand a lot about the different properties of water that help sustain life. Okay, so let's look a little closer at the atomic structure of water. So remember, atoms have electrons in their orbitals. If you look at the hydrogen part, so right here is where we're looking, you see that 2 electrons are shared to form a covalent bond. And water has 2 covalent bonds in it. Now let's look at the top of the oxygen molecule. Okay, you see 2 pairs of electrons. Okay, and those 2 pairs of electrons smooshed up at the top of the molecule give the top of the molecule a weakly negative charge. That means that these hydrogens at the bottom have a weakly positive charge. Now remember that opposites attract. Okay? So now we have a charged molecule. It's not completely charged, just a little bit. That's why we say partial. Okay? Water is also a polar molecule. So when we think about polarity, we think of a direction. Well, if we look here, we see that there's a negative charge here and a positive charge here. This is what we call a dipole moment, meaning that there's a charge on this molecule. So it's polar, and that is largely what gives water its properties. Okay, let's talk about hydrogen bonding. Okay, remember that the oxygen carries a partially negative charge, and that the hydrogen carries a partially positive charge. What that means is that there can be weak attractions between the 2 molecules. Okay? We don't have a stick there because it's not a covalent bond. It's actually a weak bond, but it's enough to attract those 2 molecules together. Okay? That's called hydrogen bonding. Okay? Hydrogen bonding is what allows water molecules to stick together in a liquid. That property is called cohesion. Okay? Now let's talk about something really interesting called surface tension. When you look at water when it's still in a cup, you notice that there's almost what looks like a film on the top. If it's clear water, you can see your reflection in it. Okay? What's happened is the water molecules are sticking more closely together than they are to the air. Okay? And that creates a tension on the water that resists penetration by other objects. Water has one of the highest surface tensions of any liquids that we know about. This helps water sustain life. Let's look at what surface tension looks like. What we're going to do here is try to get a paper clip to float. I'm first going to bend a paper clip back to make a tool, then gently lift and place a small paper clip into the water. Looky there, it's floating. Let's see if we can look at it a little closer. In your experiment, describe the interaction between the water and the paperclip. Can we get a bigger paperclip to float? Let's see. Ah, indeed, we can get two paperclips floating. Look at the water and how it interacts with the paperclip. What processes are you observing? Now that we understand surface tension, let's learn a little bit about how to disrupt it. Soap, that's a lot of soap, any kind of soap, will actually disrupt surface tension. Let's look at a demonstration and find out how. Let's look at surface tension in action. Here I have a pan of water, pepper, oregano, and parsley. You can use any of them. I chose to use parsley. Let's see what happens when parsley is sprinkled onto the water. Notice that the parsley floats. The reason it floats is because of surface tension. If I add a little bit of soap onto my fingertip and then touch the water, the soap disrupts the surface tension locally, which pushes the parsley out to the edges of the pan. In a liquid, water molecules move around randomly, but at the surface, there's far more structure because of the property of cohesion. Cohesion puts a net force towards the center of the container. As we discussed, hydrogen bonding forms between the partially positive hydrogen and the partially negative oxygen. Those hydrogen bonds help hold water together and form surface tension. Let's find out what happens when we add soap. Soap disrupts those hydrogen bonds, and that lessens the cohesive forces between the water molecules, reducing the surface tension. All right, now that we understand more about surface tension, cohesion, and adhesion, let's do some activities to further our knowledge. In the lesson today, you'll do 3 different activities. In the first 2, you'll make observations that will help you with the third activity, which is going to be developing a hypothesis. Remember the 3 things that we talked about today. We talked about cohesion, adhesion, and surface tension. All of these concepts you'll need to know as you go through our experiments. Okay. How are those naked eggs looking? Remember in lesson 1 how we poured vinegar over eggs? Mine sure look a lot different. If you haven't started your naked eggs yet, or you started a little bit late, that's okay. We won't need our eggs completely naked until next time. Make sure your eggs are skinny dipping in vinegar, and we'll look at them in our next lesson. Let's get ready for lesson 4. Okay. For lesson 4, we will be looking at seeds. You have radish seeds in your kits. If you didn't get a kit from the Science Zone, that's okay. You probably have the things you'll need at home. All you need are seeds or dried beans. So take your seeds and pour them into a cup. Okay. Then take water and completely submerge those seeds so that they are completely covered by water. Allow those to sit for 24 hours. Okay? During that time, grab your eyeballs and look at those seeds. You might notice something really quite spectacular as time goes on. It'll be small, it'll be round, but look for them and tell me what you see on Facebook. After 24 hours, divide your seeds out into 2 groups. Place a damp paper towel into 2 bags. So 2 paper towels, 2 bags. Place half of your seeds into a baggie labeled light with a damp paper towel, and half into a baggie labeled dark with a damp paper towel. Place your dark seeds into somewhere really dark that doesn't get any light. The light seeds, what you want to do is put these into a place that gets plenty of light but not direct sunlight. Don't put these on your patio or into a windowsill, because that direct sunlight will actually fry them, and then you'll get some unexpected results. Over the next several days, peek in on your seeds. Well, what are they doing? Is there any difference? Tell me in Facebook. See you soon. Thanks for joining me.